At the end of the topic, you will be able to
define chemical bond, state octet rule, explain Lewis dot structure. In a garland, the flowers are tied up by means of a thread. Unless the flowers are tied, they cannot be held together. The role of thread is to hold all the flowers together. It is more or less like a chemical bond. A chemical bond is defined as a force that acts between two or more atoms to hold them together as a stable molecule. Gilbert Newton Lewis used the knowledge of electronic configuration of elements to explain why atoms join to form molecules. He visualized the inert noble gases have a stable electronic configuration, while atoms of all other elements have unstable or incomplete electronic configuration. Elements have different electronic configurations. Different electronic configurations mean different levels of bonding. Atomic number 1, element symbol H, element configuration 1s1, number of valence electrons 1. Atomic number 2, element symbol He, electronic configuration 1s2, number of valence electrons 2. Atomic number 3, element symbol Li, electronic configuration 1s2, 2s1, number of valence electrons 1. Atomic number 4, element symbol Be, electron configuration 1s2, 2s2, number of valence electrons 2. Atomic number 5, element symbol B, electron configuration 1s2, 2s2, 2p1, number of valence electrons 3. Atomic number 6, element symbol C, electron configuration 1s2, 2s2, 2p2, number of valence electrons 4. Atomic number 7, element symbol N, electronic configuration 1s2, 2s2, 2p3, number of valence electrons 5. Atomic number 8, element symbol O, electron configuration 1s2, 2s2, 2p4, number of valence electrons 6. Atomic number 9, element symbol F, electron configuration 1s2, 2s2, 2p5, number of valence electrons 7. Atomic number 10, element symbol Ne, electron configuration 1s2, 2s2, 2p6, number of valence electrons 8. The first shell can hold up to 2 electrons and each shell thereafter can hold up to 8 electrons. G. N. Lewis named this electron theory of valence as octet theory of valence. The octet rule is a simple chemical rule of thumb that states that atoms tend to combine in such a way that they each have 8 electrons in their valence shells, giving them the same electronic configuration as a noble gas. This is also called rule of 8. Elements with stable electronic configurations have 8 electrons in their outermost shell. They are called inert gases. Ne atomic number 10 is equal to 2, 8 and Ar atomic number 18 is equal to 2, 8, 8. H would like to gain 1 electron, C would like to gain 4 electrons, N would like to gain 3 electrons, O would like to gain 2 electrons. Lewis used dot symbols to represent the valence shell electrons which make bonds. Steps to draw electron dot diagrams. Write out the chemical symbol. Find the number of valence electrons. Draw the valence electrons in the following configuration. Which among the following elements share or transfer electrons or obey octet rule? Helium, argon, lithium, chlorine. The elements that share or transfer electrons to obey octet rule is lithium and chlorine. Chlorine has only 7 electrons and lithium has only 1 electron to obey octet rule. The following elements have no stable electronic configuration. Write the electronic distribution. Sodium, carbon, fluorine, chlorine. The answer is sodium atomic number 11, electron distribution 1s2, 2s2, 2p6, 3s1. Element carbon atomic number 6, electron distribution 1s2, 2s2, 2p2. Fluorine atomic number 9, electron distribution 1s2, 2s2, 2p5. Chlorine atomic number 17, electron distribution 1s2, 2s2, 2p6, 3s2, 3p5.
In this topic, you have learnt
chemical bond, the type of force that holds two or more atoms together. This force results in the formation of a stable molecule. The first shell can hold up to 2 electrons and each shell thereafter can hold up to 8 electrons. Octet rule. Atoms tend to gain, lose or share electrons so as to have 8 electrons. This is also called rule of 8. Elements with stable electronic configurations have 8 electrons in their outermost shell. They are called inert gases. At the end of this topic, you will be able to explain the formation of a chemical bond, list the types of chemical bond, explain the favorable conditions for formation of ionic and covalent bond, draw the Lewis dot formula and structure. The atoms of a compound are held together by chemical bonds formed by the interaction of electrons from each atom. There are 3 types of bonds. They are ionic bond, covalent bond, and coordinate covalent bond. Ionic bond are a type of chemical bond based on electrostatic forces between two oppositely charged ions. It is also known as Coulombic force of attraction. Ionic bonds are formed by transfer of one electron from one atom to another. Ionic bonds are otherwise called as electrovalent bond. Formation of ionic bond: sodium 23 Na11, electronic configuration 281, 11 protons, 12 neutrons, 11 electrons. Chlorine 35 Cl17, electronic configuration 287, 17 protons, 18 neutrons, 17 electrons. The sodium atom has one electron in its outer shell, Na, Ec281 atom. The sodium atom loses one electron to leave a complete outer shell, Na plus Ec2,8 plus ion. It is now a sodium ion with the charge of +1. The chlorine atom has 7 electrons in its outer shell, Cl Ec287 atom. The chlorine gains one electron to gain a complete outer shell, Cl minus Ec288 minus ion. It is now a chlorine ion with the charge of -1. The sodium atom loses one electron to attain a complete outer shell and become a positive ion, Na+. The chlorine atom gains one electron to attain a complete outer shell and become a negative ion, Cl-. Strong electrostatic force attract the sodium and chlorine ions and form sodium chloride salt. The atom which gives off electron becomes cation and which accepts electron becomes anion. Which atoms do form cations or anions? Lithium, sodium, fluorine, chlorine. The atoms which form cations are sodium and lithium as Na plus and Li minus, Li plus. Since sodium and lithium have one electron in its outermost shell, it loses one electron and forms sodium and lithium ions. The atoms which form anions are fluorine and chlorine as F minus and Cl minus. Since fluorine and chlorine has 7 electrons in its outermost shell, it gains one electron and form chlorine and fluorine ions. The conditions favorable for the formation of ionic bond are: number of valence electrons. The atom A should possess 1, 2 or 3 valence electrons, while the atom B should have 5, 6 or 7 valence electrons. Net lowering of energy. Energy must be released as a result of electron transfer from one atom to another to form a stable ionic compound. Attraction towards electrons. A should have less attraction of electrons, hence gives off electrons, and B should have more attraction of electrons, hence gains electrons. Attracting power of bonded pair electrons by an atom is known as electronegativity. Atom with more attraction towards bonded electrons is called more electronegative element, and lesser attraction towards bonded electrons is known as lower electronegative element. Illustration: formation of magnesium chloride. Magnesium, atomic number 12, electron distribution 282. Chlorine, atomic number 17, electron distribution 287. Magnesium atom transfers 2 electrons, one to each a chlorine atom. Magnesium atom becomes Mg2 plus ion and the 2 chlorine atoms become 2 Cl minus ions, forming magnesium chloride as MgCl2. Examples of ionic bond: sodium chloride, copper sulfate, and cobalt chloride. Covalent bond is formed by mutual sharing of outermost valence electrons between two atoms. The compounds containing a covalent bond are called covalent compounds. Formation of covalent bonds: chlorine 35 Cl17, electronic configuration 287, 17 protons, 18 neutrons, 17 electrons. The outer shells of two chlorine atoms are shown. The outer electrons are shared by each chlorine atom to form chlorine molecule Cl2. Now each outer has 8 electrons. The conditionals favorable for formation of covalent bond are: the number of valence electrons. Each of the containing atoms A and B should have 5, 6 or 7 valence, so that both the atoms achieve the stable octet electronic configuration by sharing 3, 2 or 1 electron pair. Equal electron attraction. Both the atoms A and B should exhibit nearly equal attraction towards bonded pair of electrons, that is equal electronegativity. Equal sharing of electrons. Both the atoms A and B should have nearly equal attraction towards bonded electron pair. Multiple bonds enable more atoms to achieve an octet electronic configuration. Illustration 1. Formation of hydrogen molecule. Hydrogen, atomic number 1, electron distribution 1. Hydrogen, atomic number 1, electron distribution 1. Hydrogen molecule is made up of 2 hydrogen atoms. Each hydrogen atom has 1 valence electron. Each hydrogen atom contributes an electron to the shared pair and both the atoms attain stable electronic configuration. Illustration 2. Formation of water molecule. Hydrogen, atomic number 1, electronic distribution 1. Oxygen, atomic number 8, electron distribution 2, 6. Oxygen atom 2,6 has 6 valence electrons. Hydrogen atom has 1 valence electron each. Oxygen atom shares 2 electrons, 1 each, with 2 hydrogen atoms to form water molecule. Illustration 3. Formation of ammonia molecule. Nitrogen atomic number 7, electron distribution 2, 5. Hydrogen atomic number 1, electron distribution 1. Nitrogen atom 2,5 have 5 valence electrons. Hydrogen atom has only 1 valence electron each. Nitrogen atom shares 3 electrons, 1 each, with 3 hydrogen atoms to form ammonia molecule. Lone pair of molecules, lone pair of electrons are the electrons that are not involved in bond formation. Write the Lewis formula and predict the number of covalent bonds in chlorine, ammonia and fluorine. Name chlorine, formula Cl2, structure Cl, number of valence electrons 7, required 1. The Lewis formula for chlorine is, hence the number of covalent bonds in chlorine is 1. Name ammonia, formula NH3, structure, number of valence electrons N5, required 3 electrons, H1, valence electrons. The Lewis formula for ammonia is, hence the number of covalent bond in ammonia is 3. Name fluorine, formula F2, structure FF, number of valence electrons 7, required 1 electron. The Lewis formula of fluorine is, hence the number of covalent bond in fluorine is 1. A coordinate bond is a covalent bond, a shared pair of electrons in which both electrons come from the same atom. Coordinate covalent bond is usually represented by an arrow pointing from donor to the acceptor atom. Coordinate bond is also dative covalent bond. Formation of coordinate covalent bond. Reaction between ammonia and hydrogen chloride NH3 plus HCl gives NH4Cl. Ammonium ions NH4 plus are formed by transfer of hydrogen ion from hydrogen chloride to the lone pair of electrons in the ammonia molecule, representing coordinate bond. The arrow points from the atom donating the lone pair to the atom accepting it. Sulfur trioxide SO3 has the structure. How many coordinate linkages are present in this molecule? Identify the acceptor and donor atoms. Step 1. Start with the atoms and their valence electrons. Name sulfur trioxide, formula SO3, number of valence electrons, sulfur 6, oxygen 6. Step 2. Join 2 oxygens to sulfur by single covalent bonds. Step 3. Join the remaining oxygen by coordinate covalent bond. Hence, the number of coordinate linkages in the molecule is 2. The number of donor atoms is equal to sulfur. The number of acceptor atoms is equal to oxygen. Carbon monoxide is a gas. It is a coordinate compound. Structure of carbon monoxide is, identify the donor and acceptor atoms. Name carbon monoxide, formula CO, number of valence electrons carbon 4, oxygen 6. It has 2 covalent bonds and 1 coordinate bond. The arrow indicates the donation of electron. The donor atom is oxygen, the acceptor atom is carbon. Sharing of 2 pairs of electrons makes a double bond. Sharing of 3 pairs of electrons makes a triple bond. These are called multiple covalent bonds. Carbon dioxide, O double bond C double bond O, 2 double bonds. Oxygen, O double bond O, 1 double bond. Nitrogen, N triple bond N, 1 triple bond.
In this topic, you have learnt
a chemical bond is the result of attraction of 2 atoms or ions. 3 types of bond: ionic, covalent and coordinate bond. An ionic bond is formed by the transfer 1 or more electrons to another atom. A covalent bond is formed by the mutual sharing of electrons between atoms. A coordinate bond is a covalent bond, a shared pair of electrons in which both electrons come from the same atom. Coordinate bond, also called as dative bond. Attracting power of bonded pair electrons by an atom is known as electronegativity. Multiple bonds enable more atoms to achieve an octet electronic configuration. Lone pair of electrons are not involved in bond formation. At the end of this topic, you will be able to describe the properties of ionic compound, discuss the properties of covalent compound, describe the properties of coordinate compounds, discuss the exceptions to the octet rule. Common properties of ionic compounds are: these are solids due to the strong electrostatic forces, due to strong electrostatic force between the opposite ions. These ions are not in a free movement. Hence, ionic compounds are solids at room temperature. They have high melting point and boiling point. Since the plus and minus ions are tightly held in their positions, only at high temperature these ions acquire sufficient energy to overcome the attractive force causing movement. Hence, ionic compounds have high melting point. They are hard and brittle. Their hardness is due to the strong electrostatic force of attraction. When external force is applied, slight shift takes place, bringing like ions in front of each other. It causes repulsion and cleavage occurs. They conduct electricity in molten or in aqueous solution. In the solid state, the ions are fixed in their positions. Hence, they are poor conductors of electricity. In molten stage and in water solutions, the ions are free to move. Hence, they conduct electricity in molten state or in aqueous solutions. The reaction occur in faster ionic compounds gives reaction between ions. Hence, the reactions are fast. Refractory materials are heat-resistant materials. They have very high melting points. They are used in the extraction of metals from their ores. Some refractory materials are ionic compounds. Observe the solubility of sodium chloride by performing the activity. Materials required: beakers, water, kerosene and sodium chloride. Procedure: take 2 beakers, add little water to one beaker, add little kerosene to another beaker, add sodium chloride to each of the beakers. Stir it with spoon, observe the solubility. In water, sodium chloride will get completely dissolved, whereas in kerosene it does not get dissolved. Water is a good solvent of sodium chloride. Since it is a polar solvent, the positively and negatively charged end get attracted to sodium and chloride ions. But kerosene are molecules that are typically non-polar. They don't have a positively or a negatively charged end, and so they aren't attracted to charged ions. Common properties of covalent compounds. They are gases, liquids or solids at room temperature. Due to weak intermolecular forces between the molecules, covalent compounds exist as gases, liquids or relatively soft solids. They have low melting points. In solids, the molecules are held by weak forces of attraction. When heat is applied, the molecules are readily pulled out and get free movement as in liquid. They are soft solids. A molecular layer in the crystal easily slips relative to adjacent layers, thus the crystals are easily broken. They are soluble in organic solvents. These compounds readily dissolve in non-polar solvents like toluene, benzene, etc. The solvent molecules easily overcome the weak intermolecular forces of attraction. They are non-conductors of electricity. Since there are no plus and minus ions in covalent molecules, they are not capable of conducting electricity in molten state or in solution state. The reactions occur at a slow rate. In reaction of covalent compounds, the molecules as a whole undergo a change. There is no electrical force to speed up the reactions. Hence, these reactions are slow. Bonds in which electron pairs are equally shared are non-polar bonds. Bonds in which electron pairs are not equally shared are polar bonds. Identify the polar and non-polar solvent and tick out the correct answer. Benzene, water, ether, chloroform. The answer is water is a polar solvent. Benzene, ether and chloroform are non-polar solvents. Perform the activity and differentiate the solubility. Materials required: sodium chloride, paraffin wax, water, turpentine and beakers. Procedure: take water and turpentine in separate beakers. Add sodium chloride to both the solvents. Observe the solubility. Add paraffin wax to both the solvents separately in another beaker. Note the solubility. Differentiate the solubility. Sodium chloride is soluble in water. Paraffin wax is soluble in turpentine. Since water is a polar solvent, it can't dissolve. Non-polar compound paraffin wax. Similarly, since turpentine is a non-polar solvent, it can't dissolve polar sodium chloride compound. Polar solvent dissolves polar compounds. Non-polar solvent dissolves non-polar compounds. However, there are exceptions to this rule. Difference between ionic and covalent bond. Ionic bond formed by transfer of electrons from a metal to a non-metal. Covalent bond formed by mutual sharing of electrons between atoms. Ionic bond, electrostatic force of attraction between plus and minus charge ions. Covalent bond, weak force of attraction between atoms. Ionic bond, non-rigid and non-directional. Covalent bond, rigid and directional. Difference between ionic and covalent bonds. Physical state: ionic compound solid, covalent compound solid, liquid or gas. Melting point: ionic compound high, covalent compound low. Boiling point: ionic compound high, covalent compound low. Conductivity: ionic compound conductor of electricity in molten or aqueous state, covalent compound non-conductor of electricity. Nature: ionic compound hard and brittle, covalent compound soft and readily broken. Solubility: soluble in polar solvents, insoluble in organic solvents. Covalent compound soluble in non-polar solvents, insoluble in polar solvents. Speed of reaction: ionic compound fast, covalent compound slow. Common properties of coordinate compound. They are poor conductors of electricity. They are sparingly soluble in water. They dissolve in organic solvents. They are semipolar in nature. They possess melting and boiling points higher than those of purely covalent bonds but lower than ionic compounds. Atomic number of phosphorus is 15. Write the electron distribution in phosphorus. Atomic number of chlorine is 17. Write the electron distribution of chlorine. One phosphorus atom combines with 5 chlorine atoms to form phosphorus pentachloride PCl5. Which atom will have the octet? The answer is atomic number phosphorus 15, chlorine 17, electronic distribution phosphorus 285, chlorine 287, valence electrons phosphorus 5, chlorine 7. In PCl5, phosphorus has 10 electrons and chlorine has 8 electrons in its valence shell. Hence, chlorine have the octet and phosphorus do not.
In this topic, you have learnt
the ionic compounds are solids at room temperature. The covalent compounds are solids, liquids or gases at ordinary temperature. Ionic compounds have high melting points, whereas covalent compounds have low melting points. Ionic compounds are good conductors of electricity. Covalent and coordinate compounds are poor conductors of electricity. Coordinate compounds sparingly soluble in water. Coordinate compounds are semi-polar in nature. Molecules with odd number, more than octet and less than octet, are exceptions to the octet rule.